Hi, folks. I've been thinking about the concept of truth and interpretation because it's very important to everything that we'll do in the logic of relations. And I want to show you with a simple example how a sentence can have the truth value true in one interpretation and the truth value false in another. So I want to start with a simple sort of sentence that we've been using in class a lot. Maybe we can write this one down. And we know that in one of the interpretations that we use a lot, this says all scientists are philosophers. And so, for instance, I might think of a very small universe of discourse where I'm talking just about three people that I could represent with A, B, and C. And for now, if we want to, we can think of these three people as Alice, Bob, and Carlos. And what I want to imagine is an interpretation on which these folks, some of them are scientists, some of them are philosophers, some of them are both. So let's make a little chart. And let's suppose that we have a case where Alice is both a scientist and a philosopher, and Bob is both a scientist and a philosopher, and Carlos is not a scientist, but he is a philosopher. And let's try to figure out in that interpretation in which these three individuals have the properties indicated in the chart, whether the sentence that we've started with is true or false. Well, one quick thing we can do is indicate the meaning of these predicates or one-place relations, except that now, instead of writing out X as a scientist for S of X or X as a philosopher for P of X, I'm simply going to list the individuals that have the property S. And so if I look at my chart, I see that Alice and both are both scientists. So I want to list Alice and Bob. And so it doesn't matter what order I list them in. This is an unordered list, or we can just call it by its proper name, a set. And likewise, if I make a list of all the philosophers, and again, this is really a set, then I have A, B, C. Okay, very good. So now all I need to do is think about what this sentence that I started with for all x, if Sx, then Px, means in this interpretation. And the critical thing to remember here is that a universally quantified sentence is just a big conjunction. It says something about everything in my universe of discourse. So it says of A that if SA, then PA, and it says of B that if SB, then PB, and so on. So the sentence for all x, Sx, then Px becomes, in this interpretation, SA arrow PA and SB arrow PB and SC arrow PC. And now we just need to figure out the truth value of the sentence on the right, and that will give us the truth value of the sentence on the left. So, is SA true or false? Well, is it true or false that Alice is a scientist? It's true that Alice is a scientist, and it's true that she's a philosopher, so this material conditional is true. What about the next one? Is it true that Bob is a scientist? Yes. Is it true that he's a philosopher? Yes. So this material conditional is true. And what about the last one? The last one says that if SC, right, that if Carlos is a scientist, then Carlos is a philosopher. Is it true that Carlos is a scientist? No, it's not. That's false. So that automatically makes this material conditional true. So each one of the three conjuncts is true. So therefore, the truth value of this entire sentence here on this interpretation is T. This sentence is true because for any x, if x is an S, if x is a member of the set Sx here, it is also in P of x. And that's true for A, and that's true for B. And for C, the antecedent of the material conditional is false, and so because of the truth function, the way the truth functions work for a material conditional, that material conditional is true. Let's now do exactly the same thing, but show an interpretation in which this sentence is false. So we're going to start with exactly the same sentence. And now I want to use a different interpretation. And my universe of discourse is going to be, again, just three individuals. And for Sx, I'm going to have AB. And in the extension of Px, that's the proper name for this set here that I'm about to write down, is BC. So in other words, if I were to make a chart like we did on the last page with Alice, Bob, and Carlos, and this is whether or not the person is a scientist and whether or not the person is a philosopher, to think about it the way that we sometimes do in class. These extensions here show me that Alice is a scientist, but she's not in the extension of PX, so she's not a philosopher. Because remember, this list here on top, beside the SX, is just a list of all the people who are scientists. So Bob is a scientist. Carlos is not in the list of people who are scientists. Bob is in the list of people who are philosophers. Carlos is in the list of people who are philosophers. Okay? So that's the interpretation we're looking at. And now, let's do exactly the same thing to calculate the truth value of for any x, Sx, then Px. And this is going to become Sa then Pa, and Sb then Pb, and Sc then Pc. And now to calculate the truth value on the right, we do exactly the same thing we did before, but notice what happens right away when we look at this first material conditional. Sa is true because it's true that Alice is a scientist, but Pa is false because it's false that Alice is a philosopher. So this first material conditional is false. Now, I've taken some liberties in the way of writing the conjunction on the right-hand side, but we know that if we have a multiple conjunction and even one of the pieces is false, the whole thing is going to be false. So immediately I know that on this interpretation, this sentence is false. So it's very, very simple. A given symbolic sentence doesn't have a truth value until we specify an interpretation. And unless the sentence is a tautology or a contradiction, it can be true in some interpretations and false in others.